over the last few days, we've focused a lot on collecting data, interpreting data, and now we're going to start looking at how do we display the data that we have collected. We use graphs to display that data, and there are lots of different graphs that we'll talk about. Today in this video, we're just going to focus on two of them. We're going to focus on something called a bar graph and something called a histogram. So whenever we're looking to collect data so that we can graph it, you always want to start with an experiment or a question that will help you gather data. You have to know what are you looking for in order to help you display it, to make that connection. So once you've gathered your data, when you create your graph, there are three things you will always need to do. First thing is you always need to give your graph a title. You have to let people know what you are talking about, what your question was, what your research was on, and how you're displaying it on your graph. Then you want to make sure that you label the x-axis and the y-axis to let people know what two things that you were taking data on. And then the last thing you want to do, and this is typically the most difficult thing for people to do when creating graphs, is you want to make sure that you pick the right scale on your x-axis and your y-axis. And what we mean by scale, the scale is the number that you're counting by on your x and your y axis. So are you counting by 2s? Are you counting by 50s? Are you counting by 100? The scale is what helps you make sure that your data is displayed accurately. For example, if I'm talking about grades on a test, if I counted by 2s and 2 was my scale, I'm not really going to have a whole lot of data up until typically, for us at least, the 70 and above mark. So if I'm counting by 2s, 2, 4, 6, 8, 10, that means all the way from 0 to 70, there really would be nothing there. And that's the majority of our graph. So if I was going to be displaying graph data or test data, maybe counting by 10s would be a little bit better, maybe, so that way you can get really more specific and display that data better. So we're going to look at three different types of bar graphs, and we're going to start with our vertical bar graphs. So they're called vertical bar graphs because all of our bars are vertical. They're going up. And just like on any bar graph, it has a title. So this bar graph is talking about the favorite candy. It has a label on the x-axis, so candy bar choices. And the y-axis is the number of students. So I know it's kind of hard to see. I'm going to zoom in just a little. Okay. So when I look at this, I see that the four candy bars I were comparing were Milky Ways, Snickers, Twix, and Reese's. And then I see that my scale on my y-axis is they were counting by 2s. So whenever I see a bar graph, the first thing I want to do is I want to label the bars. So Milky Way, it looks like 11 people picked a Milky Way. 6 people picked Snickers. 4 people picked Twix. And 13 people picked Reese's. So my first question was to know what candy bar was chosen by the greatest number of students. So Reese's, it's our tallest bar on our graph, and we see that it has the number 13 written above it. So Reese's was picked by most students. Then the next one says, which candy bar was chosen by the fewest number of students? When I look at my graph, Twix is my shortest bar. Only 4 people chose Twix. Okay. Our next question says, how many more students chose Reese's than Snickers? So when I look at my graph, 13 people chose Reese's, 6 people chose Snickers. So that would be 13 minus 6, which is going to give me 7 students. The next one says, how many students chose Twix or Milky Way as their favorite? So when I look up here, Twix, there are 4. Milky Way, there are 11. So 4 plus 11 would give me 15 students. And then my very last question says, well, how many students took this survey? So 11 people chose Milky Way, 6 people chose Snickers, so 11 plus 6 is 17. 4 people chose Twix, so 17 plus 4 is 21. And then 13 people chose Reese's, 21 plus 13 is 34. So just by looking at our title, our labels of our axes, and labeling those bars, we were able to get a lot of information and interpret that data. Our next type of bar graph is a horizontal bar graph. Horizontal because our bars this time are going horizontal. Just like any bar graph, we have our title. So this graph is all about the hours spent practicing. The label on our x-axis is the number of hours, my scale, counting by twos. And then the label on my y-axis is these are the students. So first thing I want to do is I want to label my bars. So Rachel, it looks like she practiced for 8 hours. Ian practiced for 14 hours. Zach practiced for 5 hours. And Stella practiced for 9 hours. So our first one says, which two students spent the greatest number of hours practicing this week? So Ian was the most at 14. Stella was the next highest at 9. So Ian and Stella. Our next question, how many fewer hours did Zach practice than Ian? So Ian was at 14. Zach was only at 5. So that is a difference of 9 hours. How many hours did these students practice combined? So I need to add up all of our hours. So I would have 8 plus 14 is 22. 22 plus 5 is 27. Plus 9 is a total of 36 hours. And then our last question says, how many more hours did Rachel and Stella practice combined than Zach? So Rachel was 8 hours. Stella was 9, so that's a total of 17. Zach was only at 5 hours, so 17 minus 5 would give me 12 hours. The last type of bar graph that we have is called a double bar graph. These can be either vertical or horizontal. For example, I picked a vertical one. So with double bar graphs, they still have a title. So this one's about the minutes of homework, an x-axis label, which is teachers, and a y-axis label, which is number of minutes. But our double bar graph also gets a key. So you can know what your bars mean. So it looks like the white bars on here represent Wednesday. The black bars on here represent Thursday. So I'm going to do the same thing where I go through and I label the bars. So it looks like the first teacher we have is Miss Smith. I guess me. Let's see how y'all did on your homework. So on Wednesday, you guys practiced homework for 14 minutes. On Thursday for 16 minutes. Over in Miss Williams' class on Wednesday, they did homework for 14 minutes. And on Thursday for 10 minutes. In Miss Jones's class, we practiced homework for 16 minutes on Wednesday, 20 minutes on Thursday. And Miss Brown, they practiced for 6 minutes on Wednesday, 18 minutes on Thursday. So our first question says, which teacher's class spent the most amount of time on their Wednesday night homework? So remember, Wednesday is our white bar. So Miss Smith was 14, Miss Williams 14, Miss Jones 16, Miss Brown 6. So Miss Jones's class spent the most time on their Wednesday night homework. They spent 16 minutes. Our next one, how many more minutes did Miss Brown's class spend on their homework on Thursday than Wednesday? So when we look at Miss Brown, their Thursday night homework was 18 minutes. Their Wednesday night homework was only 6 minutes. So 18 minus 6 would give me 12 minutes. Which class spent the least amount of time on homework over both days? So since we're looking at both days, I need to add Wednesday and Thursday together. So in our class, 14 plus 16 would be a total of 30 minutes. Miss Williams' class, 14 and 10 would be a total of 24 minutes. Miss Jones, 16 and 20 would be a total of 36. And Miss Brown, 6 and 18 would be a total of 24. So it looks like Miss Williams and Miss Brown both had 24 minutes. So both of their classes spent the most time. And then our next question says, which class spent about the same time on homework both days? That would be, again, Miss Williams and Miss Brown. So again, those are our bar graphs. We always want to look for the title, want to look for your X and your Y labels, and then the scale. What are you going by? So now we're going to talk about something called a histogram. And a histogram is actually a type of bar graph. So we're going to see lots of similarities between just a regular bar graph and a histogram. So since it is a bar graph, it still is going to have a title. It's going to have X and Y labels, but the scale, we're going to get a little bit different with the scale. So the bars on a histogram, they're always going to represent frequency. So we've talked about frequency before. Frequency is how often something occurs or appears or happens. But histograms only can show the frequency of numerical data. So not categorical, only numerical data within a specific interval. And let's talk about that word interval. Interval means a range of numbers. So for example, I could have an interval of the numbers 51 through 60. Okay, looking at all of the values between 51 and 60. So again, an interval is just a range of numbers. So when we look at our example of a histogram, let's compare it to our bar graph. They both have a title. So this one, our title is the number of visits to a pool last summer. They both have an x-axis label, so number of visits, and they both have a y-axis label, number of students. Now, when I look at my y-axis, I have a scale over here on my y-axis. I'm counting by twos every single time. But when I look down at my x-axis, this is not a scale. These are those intervals that we were talking about. So my first interval is people who visited the pool anywhere from 0 to 9 times. Second interval is anywhere from 10 to 19 visits. Third one is anywhere from 20 to 29 visits. Fourth one is anywhere from 30 to 39 visits. And the last one is anywhere from 40 to 49 visits. Now, with these intervals, I can't tell exactly how many times someone went to the pool. Like when I look at my first interval from 0 to 9, I can see that 5 people went in between 0 and 9 times, but I can't tell you exactly how many times those people went. You could have had someone go all 9 times, someone go none of the times, another person go 4 times. So histograms don't give you an exact number, but they give you a frequency within a range. So 5 people went in between 0 and 9 times. 3 people went in between 10 and 19 times. 12 people went in between 20 and 29 times. 6 in between 30 and 39. And 2 in between 40 and 49 visits. So on a histogram, I can figure out how many people answered the survey. I could still add up all of these numbers and get a total. But what I can't do is I can't answer the question, and this is an example, of how many people went to the pool exactly 24 times. Again, all I know is there's a range of people who went in between 20 and 29 times, but I don't know how many people went exactly 24 times. So our big difference is from a regular bar graph, the bars on a histogram, they always touch. So you can see there's no space in between the intervals, but on a bar graph, there are spaces in between. And again, this only displays numerical data. It can't be categorical data. And we display it in ranges, or we also call them intervals.